Are we... Am I live? Looks like it. Okay. Decided to just start streaming myself doing this. Maybe get some collaboration going on. Record myself doing the work. Might make an interesting YouTube series at some point. And it's just always easier to, I don't know, it's more fun to stream stuff that you're just doing by yourself. You'd otherwise just be doing by yourself. So, I got all my cameras set up. I'm sharing a screen, sharing a display. Got chat open, so I'll actually look at that. The stream title is Resurrecting Conan CCG with AI. That's what we're going to do. We're going to resurrect a card game that never got a chance to live in the first place. So I'm just going to download Conan CCG rules PDF. Wonder. So this is the game right here. There's 196 cards. Officially there's 197, but there's one missing, I'm pretty sure. I don't know if it got canceled or what. And my goal is to simply just make it into a web app so people can play it. Host it online. Give people a way to play it. But at the same time, I want to develop kind of a methodology for creating apps like this, I suppose, that have a bunch of data to start out with. A card game. What's a trading card game? Trading card game is like a board game, but the components are really just cards. A bunch of unique cards in a set, or many different sets, usually divided into sets. So you might have a lot of cards. But for this particular game, there was only ever one set. Because of some business issues that they ran into, and the game never really got off the ground. But as you can see in the bottom section here, these cards are pretty dope. Just to give you an idea of what we're dealing with here. what we're talking about. Take a look at Headstrong Rush. I don't know if it'll focus. Take a look at that art. Take a look at that font, the colors, the text. Pretty cool, huh? Nice looking card. Got that beefcake there, Conan the Barbarian. That's what the game. That's who the game's all about. It's about Conan. Conan, Conan, Conan. As much Conan as you can possibly want. So I think it's really sick. I had learned the rules. Played a few games against myself. Got a bunch of these cards. And I decided, hey, this game's like pretty sweet. There should be a way for people to play it, you know, because there's no cards out there. They all got like destroyed by the guys who were making Conan movies at the time, evidently. But they came up with the designer came up with this game, and I think it's pretty cool. It's definitely different. It's unique. It seems like it could be really fun. I've sort of read through most of the cards. They seem balanced, you know, and well thought out, and just a solid game. A solid starting point for a trading card game that people might like to play. So, what's my plan? To use AI to build it. I've already gotten started. Step one, obviously, is to somehow get data for all the cards and put that data into a format that you can use in software. So I spent a couple of days on this website called CCG Player. Where was it? CCGplayer.net or something. I guess that's on it. CCG Player. CCG Trader. Yeah, here we go. It's not TCG Player, it's CCG Trader. And this site's actually pretty sweet. I don't know how many people like use it for sales and trades, but it's like a massive database of all these old card games. And so when I found out about this game, I came here, and sure enough, they had pretty much every card in the database for the core edition. See, there's only one set. So I was sitting here for hours and hours, just recording just looking at the cards visually, zooming up on them. Okay, this card right here, you can barely read the bottom text, but the code is 1F001. And, you know, I had to come up with variables for all the different data on the cards. Let's see. So that data is here in the resources, and it's just divided into a few different files. Action cards, ally cards, Conan cards, foe cards, item cards, move cards, and region cards. So I went through each card. Here's one, for example. Carousing. Name. So I had to come up with these variables for the data. I had to come up with names for those variables. So I called just the title of the card name. Here, I'll pull up carousing here. Here's carousing. So, name, carousing. Initiative, 3. Left side symbols, 5 elements. It's an array, which means I inputted string, null, null, shield icon, null. So that is saying what this is on the left border of the card, because that comes into play when you're in combat. Right side symbols, null, 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 grapple icon, null. Type, action, subtype, prepare, prowess cost, 2. Action effect, lose 3 prowess and choose, draw 2 or heal 3 health. Lose 3 prowess and choose, draw 2 or heal 3 health. So this is a string. This is an integer. This is just a keyword that means no data. Rareness level, very common. You can kind of see it there. It says VC. 1 VC 023 29. Card code 1 VC 029. And then image name, because I downloaded all these images as well and just gave them names locally in my on my computer. But we'll have to link this data to an image asset at some point. So that's an example of one of the action cards. So I've got all the cards in data form at this point, and I've scanned pretty much my entire collection. I acquired most of the cards. If you look over here, you can see I've got them all sorted out there in different categories. So I can quickly get to one. I can sort of, if I want a card of a certain type, I can retrieve it pretty quickly. But the reason I have all these cards is because I bought a booster box. Uh-oh, what got unplugged? Keyboard. I bought a booster box on eBay for $570. That's how rare these cards are now. It's actually probably a good deal. 36 boosters. And so that gave me a way to scan all these cards, because these images on this site are not very high res. So I needed better assets for the game. Because when you make a card game, like this one right here is pretty bad. Some of these are not that bad. But most of them are pretty bad, especially the ultra rares. Like this one, for example, is pretty terrible. Is that black? Is that supposed to look black? Like a special black card? Can't be. Anyway, some of these, I have 186 out of 196 of the cards, and I've scanned all of them. I am missing 10 of the 12 ultra rares, so like all these 4 guys I don't have. A couple other ones. Don't have Go for the Throat. I do have Speed of Hot Passion. I don't trust in Magic and a Mummery. And I don't have Iglothian Peaks. And I don't have Valeria. And I don't have Conan the Champion. So those are the cards I still need. I do have Guaranga. And I'll have a complete collection in high-res assets for every card. So, what is the plan at this point? The plan I've devised is to use test-driven development to, with AI, with Grok, to build out the game. And I'm not going to do it probably in the most practical way, because I want to test something. I want to test, like I said, a new methodology. And what I want to try to do is write at least one test for every card in the game. Probably more than one. And what I mean by that is it'll be code. Well, I'll be writing it in a certain sort of like test file shorthand that I don't have a lot of experience with, but apparently it's like a methodology for designing unit tests, test files for programming. And what a test file is a file that imports the code that you're building, or that you've started building, or that you supposedly have built and works. And the test file will import that code that you wrote and try to use it in some scenario. It will invoke its functions, and it will, pass it some data, or you'll start with some data, and the code will be imported, and it'll say, okay, run this class's function, with these arguments, and then tell me how it affects the data that we started with. Or rather, I'm going to assert that the data was updated in such a way that it is now equal to this. Is that the case? If yes, then the test passes. If not, then the test fails. And that's basically all the unit test is you're testing your code with data. You're testing that your code works with data correctly by asserting that the data is now equal to something. Now, you can do something that's called test-driven development, where instead of writing the tests after you've made the code, you write the test first, and then you write the code. So you use the test as almost like a schematic for the code. Or I guess with test-driven, in this case with AI, that's my plan, is to use it as requirements, essentially. But I think for traditional test-driven development, the idea of writing the test first is just that you're using a good practice in ensuring that you'll never have any code that you don't already have a test written for. And that's good practice, because every time you build the app, these tests run. And if any one of the tests fails, you're notified of that. The build fails. The build will not complete. And if your build doesn't complete, then you won't be able to deploy your update. You'll say, okay, the build failed. This update isn't going to work. Why did it fail? Oh, these tests failed. Why did the tests fail? What happened to our code where now it's not behaving the way we have stated that we expect it to? So, where does AI come into this? Well, my plan is to, like I said, write at least one test file. Doesn't necessarily have to be a file, but one test for each card, at least, maybe two. One where it shows the card being used in its optimal scenario, and one where it's being used in a way that it's not optimal. Because you'll see a lot of these cards have sort of conditional effects, and that's the case with a lot of trading cards. Maybe this one more than others, but because this one was designed in such a way where you could basically always have something to play from your hand, as opposed to something like Magic the Gathering, where you need to have the right number of lands or whatever. So what that means is there's a lot of scenarios where the card might have an effect, trigger when it's used. And there's situations where that effect might not trigger. So my point is, we're probably going to need multiple tests for each card. But the tests, once we have all these tests, and I'm going to use AI to help me write the tests as much as possible. I don't need to write them myself. In fact, I said I was going to write shorthand for the tests, and then give that to AI, and then have AI write the unit test code. I might actually see if I can get AI to help me come up with the tests in the first place, just by telling it, hey, I need a test for this card. You've seen me giving you all these different scenarios for these different cards to write tests for. Now I need you to help me come up with tests yourself and save me the effort, right? I'll probably try to do that at some point during the process. But the thing I really want to do is end up with a bunch of unit tests, like before any of the actual code's even written. And then I want to write a program, have AI write a program that interfaces with AI to iteratively develop an app starting from a bunch of unit tests. And I want to make it so I want to be able to start with, like I said, 400 unit tests for all of these different cards. In my project, in my IDE. It'll be, in a folder called tests, like this. See, I've already started trying to get AI to write some unit tests here. And it was having a lot of trouble. So I pretty much concluded that, hey, I need to give it better pseudocode to start with. But that's besides the point I was about to make. We're going to have like a bunch of tests in a folder here, like 400, 400 different files for every card in the game. And at that point, I want to create a program that connects to AI. And what this program is going to do is instruct AI to, it's going to have, I'm going to run it, and it's going to reference the files in these folders on my computer, and it's going to be able to update them. It will probably access Grok's X.AI API programmatically. And pass it these tests and say, hey, I've got this unit test. Can you write the code for it that it's trying to import? And it will say, okay, I need you, you know, I'll actually probably start with a few files, or already a few classes, and maybe classes for each of the cards as well. I'll do a little bit of the pre-construction, but my program will essentially be told to interface with AI and automatically update the files that it's supposed to based on what AI outputs. Then, once it's updated those files, it will run the program, or it will try to build the Java program. The tests will almost certainly fail. They will certainly fail while the AI is getting started. And my program will automatically take the output from the error logging that the JUnit test library will output, and it will give that back to AI and say, okay, AI, I implemented your changes. Here's the, updated file that I modified. Maybe I'll remind it of where the file's at. I tried to build the app. The test failed. It gave us this output. Here's exactly where the test failed. We need to update, and then so I'll say we need to update. We need to try again. You need to update the source code again. AI will do its thing, try to fix it. My program will take what AI outputs. That part might be a little bit difficult. Maybe not. I don't know. It will take the code that AI outputs and update my source files, then run it again, pass the output back to AI again. So I'll create like a loop, like a run, edit, run, prompt AI, edit, run loop. So theoretically, I can go from a whole bunch of test code to a fully functioning game after enough iterations with the AI prompting itself, assuming my program works correctly. And assuming I wrote all of the tests in such a way where none of them conflict with each other. That's an important facet. I can't, say this test runs and resolves this way, while this other test uses the same card, runs and resolves this way, in a way that's contradictory. I mean, the AI will probably still get those tests to pass, find a way to make those tests pass, but they could really mess it up if the tests were written in a way that's flawed. So that's it. That's the plan. So it's a lot of upfront work. But I think I pretty much know what I need to do. It's just going to be a lot of prompting Grok and coming up with gameplay scenarios that conform to the rules of the game. So the first thing I'm going to do is be like, hey, Grok, what's that methodology for writing test file pseudo code in plain English? No, I'm talking about the format where it's like when ... then ... and ... then ... You know, what's that called? Given, when, then. Behavior-driven development. GWT. Popular because it bridges the gap between technical and non-technical team members. Isn't there a library or something that takes this kind of text as input and generates test files? Gherkin, that's what I was trying to remember. Alright, so I was trying to remember Gherkin. Gherkin.io. Gherkin, 10-minute tutorial. What is this? Java. Install Cucumber. Write your first. Create an empty Cucumber project. Given, when, then. Scenario. Okay, Cucumber is a tool that supports behavior-driven development. If you're new to behavior-driven development, read our BDD introduction first. Okay, so my plan here is to write a bunch of tests, unit tests for a card game called Conan CCG from 2006, and I want to use you to write most of the tests, but since I understand the rules of the game well, I think it's best to write some kind of BDD style pseudo test code, which you can then translate into unit tests. Is that basically what Gherkin does? Yes, you're exactly on track. Gherkin, the language used in given, when, then format is designed to let you write human-readable behavior-driven development style test scenarios that describe how a system like your Conan CCG card game should behave. Since you understand the rules of the Conan collectible card game, writing Gherkin-style pseudocode is a great way to outline test cases based on the game's mechanics, which I can then help translate into actual unit tests in a programming language of your choice. Let's break this down in plain English. Confirm your plan and clarify Does Gherkin do what you want? Gherkin does exactly what you're describing. It lets you write test scenarios. These scenarios act like pseudocode. Gherkin scenarios are stored in .feature files, parsed by BDD tools like Cucumber to either run tests, if step definitions are implemented, or generate test code skeletons. Plan to write have for the Conan and have me convert it to unit tests is spot on. Gherkin will let you define the game's rules and interactions as test cases, and I can generate a corresponding test code, filling in the logic based on your description or additional details about. I will do this. You write Gherkin scenarios. I translate to unit tests. Iterate and refine. Feature. Playing a character card. Scenario. What I to do. Great. Sounds like a good plan. There are 196 unique cards in this card game, and a rule book. After we've written a bunch of I want to use test-driven development to build this app in Java. I'm thinking it will be best to decide what classes we want first. Should there be a class for each card? Should each card implement a card interface? Should there be different interfaces for the different types of cards? Should we define a game manager class? Should we define a player class? If you want more detail on the elements of this game, ask me and I will provide them. I would like to start by constructing a skeleton of the game, or perhaps with a bunch of files. And perhaps we can also utilize .puml diagrams at this point. And we can go back and forth until it looks like we've spec'd it out well from a high level. Which reminds me, I need to install the particular plugin for where's the plugins? Hello? Where's the plugins? That's not. Settings. Plugins. Pummel. Pummel parser. Install. Accept. I thought it was already installed. I guess maybe on a different account. Did it work? Pummel. Pummel. PUML. I hit install. Okay. All right. I think that should work. So what this is pretty cool. This is a plugin. Oh, Pummel for idea. Here we go. Okay. Restart. Yeah, so what this is really cool. PUML library. It's like a certain markup language. That translates, as you can see, into
Purgaries. Kind of like the in-betweeny one. You weren't really shit, but you weren't all that great either. Like Tottenham. Do you believe in all that stuff, Ken?
like Tottenham.
Tottenham.
It's funny. So we've got a UML diagram here. Oh yeah, I forgot that. Back to the high level. I've already started a little bit on a different conversation. Here is some of the PUML diagrams. So I think this is a really cool way to interface with AI, as well as the whole unit tests idea. You use .puml to talk about how you want the app to be structured before you even start building it. So like I'll pass it this information and it will see what I was talking about in the other conversation. Game architecture, all this stuff. resolve queue, stuff that I was working on before. So I'm going to pass all that information and just be like, hey, so this is what I had in a previous conversation. What I want to decide is exactly what classes we want to start with in the project before we start writing unit tests for them. Once we have all the unit tests written, we will proceed to implement the source code into the files we already created in a process of running the tests, examining the test output errors, and updating the source code before running the tests again. As you can see, we will use a bunch of unit tests as the requirements for this card game. But I think it will be the easiest for you to update files that already exist instead of making new ones, as I will write a program that can interface with my files on my computer, as well as prompt you with updated prompts and run the build on my app, card game app, after files are updated in response to your prompts. So let's start with figuring out exactly how we're going to design this app with object-oriented programming practices and features in Java. I will create the files in the correct folders with the correct names and class types in Java. And once that's done, I'll start writing the Gherkin use cases for the cards in the game, and then give those to you to translate into unit tests for each card. At least one test each. Sound like a plan? Let it enter, and then hopefully it'll think hard using Grok 4. Whatever. You see, I just kind of like to talk to AI like this because it helps me get my ideas sort of out on paper. So yeah, we've got all these UML diagrams already. info, draw phase, game architecture. So this right here. Game manager, game state, player, chronicle area, bot player. See, this is the stuff I'm not sure about that I kind of want to figure out in this PUML. Before I even start writing tests. Because this will help me understand what I'm trying to build out with the tests. Based on the PUML diagrams and descriptions from a previous conversation, plus my understanding of the Conan CCG rules, prowess, I agree with your plan. Using TDD in Java is solid. We'll define the class skeleton first via OOP principles, create empty files / packages, then use Gherkin scenarios to drive unit tests, and implement the source code iteratively based on test failures to keep it OOP friendly. Encapsulation. Classes like card entity will hold data, e.g. names, cost, effects, and behavior. Inheritance, polymorphism. Use an interface, e.g. composition, abstraction, single responsibility. Avoid a class per card. With 196 cards, make card entity data driven. Load stats, effects from JSON. Effects can be implemented as lambda strategy patterns or scripted. No need for separate classes per card. Use one card entity with classes with, okay, that makes sense. Proposed class design. We build on your existing PUML with refinements. I've incorporated card types via enum or subclasses, phases, queues, timers, combat resolution, win conditions, support for bots, persistence, WebSocket, card interface, card entity, effect interface, action, player, bot, abstract class, game state, game manager. See, this is what I needed to think about, because I'm not an OOP programmer. I'm a JavaScript programmer for the most part, and but I know that for building large systems like this, there's nothing better than object-oriented programming with all these different systems of defining, attributes and just simulating complex systems. That's what OOP is all about. Doing it in such a way where you can work on it and build it and change it easily, understand it. I refined your class diagram, PUML, for OOP alignment. Added phase enum, made player. You can copy and paste into plant UML to visualize. Interface card entity, card type, game state. Okay, so here we go. Let's see, it's already updated. Might be a little, oh, okay. So this is what I need to, this is what I want to start with. I want to study this, and I want to make sure it makes sense. Because there's such a thing as design patterns, and there's such a thing as anti-patterns, like anti-design patterns. So this is a good starting point. What did it do? I don't know what these arrows mean. I don't understand UML. Okay, I understand this. So this is a class. This C means class. These arrows. Actually, I could probably reference the text here as like an explanation. Like if I went down to Game Manager, right here, and I looked at, or maybe I went to Game State, and I looked at. I need glasses, man. Game state. Anyway, I'll come back to this later. Um, this is a good start. Got a separate. Hey! I'm talking to my stream. I was just about to turn it off. I'm doing something on my computer. I don't think anybody's watching the stream, but